This is the question I was talking about. This is a nice question. GATE 1990 question. GATE 1990 question. See, those students who have already studied from somewhere else, many students, they think like this. See, I have seen this is a misconception. Now I am going to take some really nice GATE questions. These are the misconceptions that 2NF doesn't have partial dependency. 2NF doesn't have partial dependency. Okay, 2NF doesn't have partial dependency. This is a misconception. 2NF doesn't have partial dependency. 3NF doesn't have transitive dependency. 3NF doesn't have transitive dependency. Doesn't have transitive dependency. These are misconceptions. Okay, these are misconceptions. These are wrong. Is this clear? Now you might be thinking, see, let me tell you, these are wrong. Okay, now let me tell you one thing. Many students, many students in the last 20 years, maybe 15 years, last 20 years, you can check on the Gateoverflow website, you can check in the Telegram groups, you can check their notes. Okay, many students who are learning from many different, I can say non-standard resources. Okay, so they have these misconceptions. Now let me tell you one thing. There are GATE questions using which they can clear their misconception, but still I don't know how they are solving these questions. For example, this is what they will say. They will say, okay, 2NF doesn't have partial dependency, 3NF doesn't have transitive dependency. This is what they will say. But now you can notice, for this question, what will be your answer? For this question, what will be their answer? Tell me, this is the question. Which of the following is false? This is MCQ question. Which of the following is false? Tell me. Which of the following is false? First, let's solve by our correct concepts. First, apply your correct concepts. Let's apply your correct concepts. So, okay, just apply your correct concept. This is the question. Let's apply. This is the question. Let's apply all the correct concept that you have seen, you have studied. Any relation with the two attributes is in BCNF. Can I say? Can I say, is this in BCNF? If a relation has two attributes only, then see, what are the possibilities? If your relation has two attributes only, what are the possibilities? Tell me, what are all the possibilities? If your relation has two attributes, then what are the possibilities of non-trivial FDs? What are the possibilities of non-trivial FDs? What are the possibility of non-trivial FDs? What are the possibilities? The first possibility is no non-trivial FD. The first possibility is non-trivial FD. If you don't have non-trivial FD, then there is no problem. Yes or no? Correct? If you don't have non-trivial FD, then there is no problem. If there is no non-trivial FD, in this situation, what will be the candidate key? If you have no non-trivial FD, if there is no non-trivial FD, in this situation, what will be the candidate key? That will be AB. So if you have no non-trivial FD, there is no problem. Correct? In this situation, can you have, tell me, if there is no non-trivial FD, if there is no non-trivial FD, what will be the candidate key? Can it be A? Can I say it will be A? Can I say it will be A? Can I say it will be A? What is wrong here? If you say it is A, then why? What is the answer? If you say it is A, then what will happen? If you say it is candidate key, if you say it is candidate key, then it means A determines B. This is non-trivial FD. Is this clear? Tell me. If you say this is non-trivial, if you say this is candidate key, if you say this is candidate key, then A determines B, which is non-trivial FD. So this cannot happen. Can I say this? The same logic. The same logic. This also cannot happen. What about this? This is correct. Okay. So in this situation, candidate key will be AB. So if you don't have any non-trivial FD, no problem. Your relation will be in BCNF. There is no violation, no BCNF violation. Second point, if you have A determining B, then also there is no problem. Then also it is in BCNF. Third, B determining A, then also BCNF, there is no problem. Then it is BCNF. And the fourth, A determining B, B determining A, then also BCNF. So there is no violation. So if you have two attributes, then it will be in BCNF. Your relation will be in BCNF. So this is actually true. This statement is actually true. What about the second? What about the second? A relation in which every key has only one attribute. In which every key has only one attribute. Key means what? Tell me. Key means what? This word key. This means what? Key means candidate key. So if every candidate key has one attribute, then if every candidate key, has one attribute, then this is also true. Then it is in 2NF. Because now you cannot create a partial dependency. Now you cannot create a partial dependency where candidate key determines non-prime attribute. Now you cannot create proper subset of candidate key. In this situation, you cannot create proper subset of candidate key. What about the next one? What about option C? A prime attribute can be transitively dependent on a key in 3NF. No problem. It is fine, right? We don't have any problem. Yes or no? Prime attribute can be transitively dependent. There is no problem. Prime attribute can be transitively dependent. So this type of transitive dependency can be there. Agree or not? This transitive dependency is fine. This transitive dependency is fine. Agree? So this transitive dependency is fine. We have already seen this. This transitive dependency is fine. This transitive dependency is allowed in 3NF. At this point, can you notice? Okay, just wait now. Now can you notice those concepts like 3NF does not have transitive dependency? Those concepts are wrong. Can you notice? This gate question is saying that those concepts are wrong. Please read this question and tell me. Those concepts are wrong, right? When someone says 3NF cannot have transitive dependency, 3NF cannot have transitive dependency, those concepts are wrong. The gate question itself is telling you yes or no. So there is a gate question which is shouting that your questions are wrong, your concepts are wrong. There is a gate question which is screaming like your concepts are wrong. Still students are learning the same wrong concepts. Like, let me tell you, I don't understand how they are solving this question. For last say 7 years they are solving this question. So this is 2007 question. This is 2007 question. For last 15 years people are solving these questions. I don't know how they are solving this question, because many students, majority of the students, they have misconceptions, and using those misconceptions you cannot solve this question, right? Yes or no? Okay, anyway, so basically this transitive dependency is fine. You can take example. You can take the example for 3. Let me tell you actually what happens. It happens that once you get the right answer, basically what many students do, this is a problem with many students. What they do, once they get one option, like, okay, once they get, for example, once they get this is false, then they don't care about the remaining. Once the question is asking false, this is false, so I don't care about the remaining. I don't care about this. So this is the problem with many students. So you should not do this. Anyway, so let's see this third one. Tell me, can you give me a relation 3NF which has transitive dependency? Consider this relation R, A, B, C, D, where AB determines CD, CD determines A, and A determines C. Can you notice this is in 3NF? This is in 3NF. Why? Because there is no known prime attribute. There is no known prime attribute. So because there is no known prime attribute, so automatically this is in 3NF. Okay, now you tell me, do we have transitive dependency? But this is the transitive dependency. Look at this. This is the transitive dependency. AB determining C. This is your transitive dependency. This is your transitive dependency. Here, in this transitive dependency, what is happening in this? In this transitive dependency, what is happening? AB determining C. This is transitive dependency. Notice. Why this is transitive dependency? Because AB can determine A. AB can determine A can determine C. A cannot determine B. So this is a transitive dependency. So I can say this AB determining C is transitive. Is transitive dependency. Can you notice? So I can say this is a candidate key. This is the prime attribute. So a prime attribute can be transitively dependent on key, yes or no? Agree or not? See this. So a candidate key, a prime attribute can be transitively dependent on candidate key. A prime attribute can be transitively dependent on candidate key. This is what I'm saying. So in 3NF, a prime attribute, the relation is in 3NF. So in 3NF, a prime attribute can be transitively dependent on candidate key. Can be transitively dependent on candidate keys. Can be dependent on candidate keys. Is this clear? So a prime attribute, we don't care about prime attribute. A prime attribute can be transitively dependent on candidate keys. It can be. So this is your option number C. What about option number D? What about option number D? A prime attribute can be transitively dependent on key in BCNF. In BCNF, a transitive, it can, okay, so this is not possible. Why this is not possible? Tell me why this is not possible. This is not possible because every non-trivial FD, LHS is super key. Why this is not possible? Notice that in BCNF, very simple point, in BCNF, every, this is very important. Every non-trivial FD, if you take any non-trivial FD, so any non-trivial FD, what will happen? Every non-trivial, okay, every non-trivial FD, in every non-trivial FD, LHS is super key. Okay, LHS is super key. This is my question. In BCNF, can we have candidate key transitively determining some prime attribute? Candidate key transitively determining some prime attribute A. Candidate key alpha. Can we have this? Remember the definition of transitive dependency. Recall the definition of transitive dependency. What is that? Recall the definition of transitive dependency. What is that? Definition of transitive functional dependency. What was that? Do you remember? I told you that alpha, if you have alpha determines beta, determines A, where beta does not determine this, and also A should not belong to beta, A should not belong to alpha. Do you remember this? The complete definition I told you. A should not belong to alpha, A should not belong to beta. Okay, A should not belong to alpha, A should not belong to beta. This was the definition. This was the complete definition. So alpha goes to A is transitive. This was the definition. This was the complete definition. Now you tell me, in the BCNF, can you have this? In the BCNF, can we have this? Let's assume BCNF, we have this. In BCNF, let's assume this is candidate key. Okay. And let's assume it is subset of alpha. Let's assume it is subset of alpha. Maybe some subset of alpha. Let's assume this is some subset of alpha. Okay. And let's assume here you have A. Okay. So it is looking like that it is possible. It is looking like yes or no. It is looking like that this is possible. But what is the problem here? What is the problem here? What is the problem here? This is the problem. This is the problem. This is a non-trivial FD or not? Tell me, this is a non-trivial FD or not? This is a non-trivial FD or not? Why this is non-trivial FD? Tell me. Anyone? Anyone? Why this is non-trivial FD? Anyone? Why this is non-trivial FD? Anyone? Why this is non-trivial FD? Tell me why this is non-trivial FD? Why this is non-trivial FD? Because this is single attribute and this does not belong to beta. Because this is single attribute. Why? Okay, this is a very simple concept. This is a single attribute and alpha does not belong to beta and A does not belong to beta. So this is non-trivial FD or not? A does not belong to beta. A does not belong to beta. And A is single attribute. This is your non-trivial FD. So what should happen? So what should happen? So beta is candidate key. So beta is super key, right? So this beta is super key because your relation is in BCNF. Because your relation is in BCNF. Is this clear? Because your relation is in BCNF. So this beta is super key. So there is a contradiction. So beta can determine alpha. Contradiction. Contradiction. Tell me, did you get it? This complete analysis. Did you understand this complete analysis of this question? Tell me. The complete analysis. So in BCNF, can we have this type of situation? Can we have this type of situation? So this is no. The answer is no. This is the complete analysis of this question. So remember, in BCNF, this cannot happen. This is not possible. A prime attribute is transitively dependent on a key. In BCNF, this is not possible. So finally, this will be your answer. The question is asking for false statement. Your answer will be option D. Is this clear? Is this crystal clear? Like, do you have any doubt? Why beta goes to A is non-trivial? Tell me. See, tell me, if this is beta and this is a single attribute, this is a single attribute, this is a single attribute, A does not belong to beta. So can I say this is A does not belong to beta? So can I say this is, tell me, A does not belong to beta. So can I say this is non-trivial? Clear? Let me know. But relation is in BCNF. So beta has to be, this is what I am saying. This is what I am saying. This is the contradiction, Nikhil. This is the contradiction we are getting. If this is non-trivial, then beta must be super key. If beta is super key, then beta determines alpha. So there is a contradiction. So we got a contradiction. Is this clear? So we got a contradiction. So remember, in BCNF you cannot have this type. So in BCNF you cannot have this. Okay, you cannot have any candidate key transitively. Okay, any candidate key transitively determining prime or non-prime. This you cannot have. Okay, one by one I am telling you. This you cannot have. Transitively determining prime, this you cannot have. Okay. Similarly, candidate key partially determining prime, this also you cannot have. Okay, is this clear? And the same thing you can say for non-prime also. The same thing you can say for non-prime also. So transitively determining this and transitively determining this. So this type of non-trivial functional dependencies you cannot have. You cannot have. Is this clear? Tell me. So these type of dependencies are not there. Okay, now let's see then this question. What about this question? Tell me. This is GATE 1990 question. Which of the following statements are true? A relational database in 3NF may still have undesirable things because it may still have undesirable data redundancy because there may exist. In 3NF, there may exist. So tell me, can we have transitive dependency? In 3NF, can we have transitive dependency? Which is in 3NF, may, okay, so can we have transitive dependency? Yes, you can have. Correct? Okay, so yes, you can have. What about the next? Non-trivial functional dependency involving prime attributes on the right hand side. This is also fine. This is also fine, right? No problem. No problem. Okay, non-trivial functional dependencies involving prime attributes only on LHS. Non-trivial functional dependency involving prime attributes only on LHS. Means on RHS, who is there? On RHS, who is there? On RHS, non-prime. On RHS, you have non-prime. That is not allowed. Yes or no? That is not allowed. In 3NF, this is not allowed. I told you. In 3NF, everything is allowed, but this is not allowed. I can say not a super key implies non-prime attribute. Not a super key implies non-prime attribute. This is not allowed. Is not allowed. Okay. So this is not allowed. This we have already seen. In 3NF, this is the problem. In 3NF, you must not have this. So you can notice. So option C is false. Why? Because of this word only. Because of this only word. Because it is saying that prime attributes are only on LHS. Means on RHS, you have non-prime attribute on RHS. That is the problem. What about this one? Involving only prime attribute. This is fine, no problem. This is fine, there is no problem, right? Why are you getting redundancy? Why you are getting undesirable redundancy? Because of this situation, can you get undesirable redundancy? Tell me. This is my question. Because of this situation, not a super key implies prime attribute. Because of this situation, can you get unnecessary redundancy? Can we get undesirable redundancy? Undesirable data redundancy means data will be redundant. Okay, so because of this, so the answer is yes. The answer is yes. Let me take one example. Consider this ABCD. This is a relation, and let's assume AB determining CD and CD determining AB, A determining C. Now here what will happen? See, this is in 3NF, right? Correct? This is in 3NF, but still you can notice this type of situation. Can you notice what is happening here? Tell me what is happening here. This is not super key. Can you notice this is not super key? And can you notice this is a prime? Not super key. This generates prime. So there is a redundancy. This can create redundancy. This can create a lot of redundancy. Can create a lot of redundancy. What is that? How can it create redundancy? Just think about it. Just think about it. This is your table A, B, C, D. Okay, and your A determining C. Now notice what will happen. Let me write it here. A, let me write like this. Now notice what will happen. See, whenever I repeat this, let's assume there are 10,000 records. Okay, let's assume there are 10,000 records. Let's assume there are 10,000 records where you have two. Then automatically what will happen? Automatically what will happen? This is redundancy or not? Can you notice unnecessary redundancy? Just think about it. Like for example, if you write this every time, just think about it. Jaipur determines Rajasthan. If you write this, okay, let's assume you write this 10,000 times Jaipur. This Jaipur, you write it 10,000 times. Let's assume you write it 10,000 times. Then this is redundancy or not? If you have to write this again and again, if you have to write this again and again, this is redundancy. This is redundancy. Unnecessary. This is unnecessary. The same data you are repeating. What is the better solution? What is the better solution? What is a better solution? The better solution is just put a different table. Just create a different table. So what is a solution? A solution is very simple. Just create a different table where you have district and where you have state. Just create a different table. Now there will be no such redundancy. Now it will come only once. This data will only store one. You will store this data only one time. This data will be stored only one time. Correct? Okay. So like this. Ekta is asking, can be repeating in any functional dependency? Yes. In any functional dependency, this will happen. Apart from, except in BCNF. If your LHS is super key, then it will not happen. Ekta, why? Tell me. Why? Tell me. If your LHS is super key, then it will not happen. If your LHS is super key, then it will not happen. Why? Because it will not repeat. Because it will not repeat. The LHS will not repeat. So the RHS will not repeat. Yes or no? LHS is not repeating, so the data will not repeat. That we will see in the next class. In the next class, we will see. May repeat some tuple. Why? Why? Tell me. If your LHS is not repeating, then RHS will also not repeat. You are super key. LHS is super key. If you have super key, tell me. If you have a table R, A, B, C, D. Okay, tell me. And let's assume you have this AB determining CD. Let's assume you have this. Or maybe you have something like this. A determines BCD. Now notice this is super key. Now it will not repeat because it's super key. So this cannot repeat. Yes or no? This cannot happen. Agree or not? This cannot happen. Yes or no? Is this clear? It will not repeat. That is the point of super key. What is the point of super key? In BCNF, what is the point of super key? Tell me, what is the point of super key? So it cannot repeat. Super key row cannot repeat. Super key cannot repeat. So it is not repeating. So because it is not repeating, so Now tell me, is this redundancy? Is this redundancy? Tell me, is this redundancy? Anyone? Is this redundancy? This is not redundancy. Why this is not redundancy? Because this is the unique data for this. This is the unique data for this. This is the unique data for this. It's like this is not redundancy, right? For example, if I say Kota, Rajasthan, okay. If I say Jaipur, Rajasthan, will you consider this as redundancy? Tell me, will you consider this as redundancy? This is not a redundancy. This is one information. This is another information. This is one piece of information. This is another piece of information. So this is not a redundancy. Okay. Now, so tell me here. So is this question clear? What is the answer? So which statement is true? For this question, which statement is true? The answer will be this is true, and this is true. Okay. Answer will be ABD. So these are some gate questions that we have seen. Tell me, did you understand all the concepts? Did you understand? Like crystal clearly, I have explained every concept, all the variations, like whatever variation has come to my mind, whatever variation I found on the internet, I've taken it. So tell me, did you clearly understand this? You can work it out. Okay, just work it out. Just study this. This is a very simple topic. Let me tell you. This is a very, very, very simple topic. This normalization, normal form, BCNF, 2NF, 3NF, okay, 1NF. This is a very simple topic. Very simple topic. Once you understand this, many good questions you can solve. And if you have those misconceptions, those misconceptions, like those are wrong concepts. Like 2NF cannot have partial dependency, 3NF cannot have transitive dependency. Those are wrong concepts. And there are gate questions. Remember, there are gate questions which are telling you that those are wrong concepts. In gate already there are questions which are telling you that those are wrong concepts. I don't know, still you will find, okay, let me tell you, it is true. And this is the, I can say, this is unfortunate in the coaching industry. You can check it out. Check all the notes of your friends who are learning from non-standard resources, who are learning from some random YouTube videos or learning from some coaching institute. Check their notes. So you will find these type of, all these misconceptions you will find in the normalization. In the partial dependency definition, you will find the misconception. Partial dependency definition. Transitive dependency definition will be not there. Let me tell you. Transitive dependency definition will not even be there in the notes. There will be no definition of transitive dependency. They will use the word transitive dependency definition. They will use transitive, but the definition will not be there. Okay. And 2NF, 3NF, all these misconceptions, all these wrong concepts will be there. So anyway, you don't have to worry about it. After the GATE exam, you can do that. Okay. After the GATE exam, you can maybe for 5 or 10 days, you can check it out. Okay. And once you check all the resources, not NPTEL, because those are the standard resources. We are also learning from NPTEL. We are also learning from like whatever we are teaching you in the Go classes, we are learning from standard resources. We are learning from NPTEL, from MIT, from all the standard resources we are learning. Okay. But all the non-standard resources I'm talking about, okay. So you can check it out. And once you check it out, then after that, you can recommend Go classes to the students. Okay. Okay. So like that, because it happens, they will teach you in a very easy manner. Nowadays, all the teachers, they are very experienced. So they know how to teach you all the easy concepts in easy manner. They will teach you easy concepts in easy manner. And the students will think, oh, so here's a God, because he is teaching you easy concept in easy manner. They will not even touch the hard concept. Hard concept, they will not touch. And if they touch the hard concepts, they will either teach it wrong, or they will make you by heart. They will give you a table, just by heart this table, just by heart this formula, by heart this procedure, by heart this theorem. Okay, so something like that. Anyway, so forget about that, all these things. Okay, anyway.